Fax, sometimes called telecopying or telefax, is the telephonic transmission of scan-printed material, normally to a telephone number connected to a printer or other output device. The original document is scanned with a fax machine, which processes the contents as a single fixed graphic image, converting it into a bitmap, and then transmitting it through the telephone system in the form of audio frequency tones. The receiving fax machine interprets the tones and reconstructs the image, printing a paper copy. Early systems used direct conversions of image darkness to audio tone in a continuous or analog manner. Since the 1980s, most machines modulate the transmitted audio frequencies using a digital representation of the page, which is compressed to quickly transmit areas which are all white or all black. Fax in the 21st century. Although businesses usually maintain some kind of fax capability, the technology has faced increasing competition from internet-based alternatives. Fax machines still retain some advantages, particularly in the transmission of sensitive material which, if sent over the internet unencrypted, may be vulnerable to interception, without the need for telephone tapping. In some countries, because electronic signatures on contracts are not yet recognized by law, while faxed contracts with copies of signatures are, fax machines enjoy continuing support in business. In Japan, faxes are still used extensively for cultural reasons. In many corporate environments, freestanding fax machines have been replaced by fax servers and other computerized systems capable of receiving and storing incoming faxes electronically, and then routing them to users on paper or via an email. Such systems have the advantage of reducing costs by eliminating unnecessary printouts and reducing the number of inbound analog phone lines needed by an office. The once ubiquitous fax machine has also begun to disappear from the small office and home office environments. Remotely hosted fax server services are widely available from VoIP and email providers, allowing users to send and receive faxes using their existing email accounts without the need for any hardware or dedicated fax lines. Personal computers have also long been able to handle incoming and outgoing faxes using analog modems or ISDN, eliminating the need for a standalone fax machine. These solutions are often ideally suited for users who only very occasionally need to use fax services. History, wire transmission. Scottish inventor Alexander Bain worked on chemical-mechanical fax-type devices and in 1846 was able to reproduce graphic signs in laboratory experiments. He received patent 9745 on May 27, 1843 for his electric printing telegraph. Frederick Bakewell made several improvements on Bain's design and demonstrated a telefax machine. The pantograph was invented by the Italian physicist Giovanni Casely. He introduced the first commercial telefax service between Paris and Lyon in 1865, some 11 years before the invention of telephones. In 1881, English inventor Shelford Bidwell constructed the scanning phototelegraph that was the first telefax machine to scan any two-dimensional original, not requiring manual plotting or drawing. Around 1900, German physicist Arthur Korn invented the billed telegraph, widespread in continental Europe especially, since a widely noticed transmission of a wanted person photograph from Paris to London in 1908, used until the wider distribution of the radiofax. Its main competitors were the bar copyright linography by a Permilde Bellon first, then since the 1930s the Hellschreiber, invented in 1929 by German inventor Rudolf Hell, a pioneer in mechanical image scanning and transmission. The 1888 invention of the telautograph by Elisha Gray marked a further development in fax technology, allowing users to send signatures over long distances, thus allowing the verification of identification or ownership over long distances. Wireless transmission. As a designer for the Radio Corporation of America, in 1924, Richard H. Ranger invented the wireless photoradiogram, or transoceanic radio facsimile, the forerunner of today's unregistered trademark S-fax machines. A photograph of President Calvin Coolidge sent from New York to London on November 29, 1924 became the first photo picture reproduced by transoceanic radio facsimile. Commercial use of Ranger unregistered trademark S product began 2 years later. Radio fax is still in common use today for transmitting weather charts and information to ships at sea. Also in 1924, Herbert E. Ives of AT&T Corporation transmitted and reconstructed the first color facsimile, using color separations. Around 1952 or so, Finch facsimile, a highly developed machine, was described in detail in a book. It apparently was never manufactured in quantity. In the 1960s, the United States Army transmitted the first photograph via satellite facsimile to Puerto Rico from the Deal test site using the Courier satellite. Telephone transmission, a landmark year was 1964, in which the Xerox Corporation introduced what many consider to be the first commercialized version of the modern fax machine, under the name or long-distance xerography. This model was superseded 2 years later with a unit that would truly set the standard for fax machines for years to come. Up until this point, facsimile machines were very expensive and hard to operate. In 1966, Xerox released the MagnaFax telecopier, a smaller, 46-pound facsimile machine. This unit was far easier to operate and could be connected to any standard telephone line. This machine was capable of transmitting a letter-sized document in about 6 minutes. The first sub-minute, digital fax machine was developed by Dacom, which built on digital data compression technology originally developed at Lockheed for satellite communication. By the late 1970s, many companies around the world entered the fax market. Very shortly after, a new wave of more compact, faster and efficient fax machines would hit the market. Xerox continued to refine the fax machine for years after their groundbreaking first machine. But, in later years, it would be combined with copier equipment to create the hybrid machines we have today that copy, scan and fax. Some of the lesser-known capabilities of the Xerox fax technologies included their Ethernet-enabled fax services on their 8,000 workstations in the early 1980s. Prior to the introduction of the ubiquitous fax machine, one of the first being the Exxon Quip in the mid-1970s, facsimile machines worked by optical scanning of a document or drawing spinning on a drum. The reflected light, varying in intensity according to the light and dark areas of the document, was focused on a photocell so that the current in a circuit varied with the amount of light. This current was used to control a tone generator, the current determining the frequency of the tone produced. This audio tone was then transmitted using an acoustic coupler attached to the microphone of a common telephone handset. At the receiving end, a Handster Euro 1 registered trademark S speaker was attached to an acoustic coupler, and a demodulator converted the varying tone into a variable current that controlled the mechanical movement of a pen or pencil to reproduce the image on a blank sheet of paper on an identical drum rotating at the same rate. A pair of these expensive and bulky machines could only be afforded by companies with a serious need to communicate drawings, design sketches or sign documents between distant locations, such as an office and factory. Western Union began a facsimile telegraphy service in 1935. Their first coast-to-coast message contained images of Mickey Mouse. Computer facsimile interface. In 1985, Dr. Hank Magnuski, founder of Gamma Link, produced the first computer fax board, called Gamma Fax. Capabilities. There are several indicators of fax capabilities: group, class, data transmission rate, and conformance with ITU-T recommendations. Fax machines utilize standard PSTN lines and telephone numbers. Group, analog. Group 1 and 2 faxes are sent in the same manner as a frame of analog television, with each scanned line transmitted as a continuous analog signal. Horizontal resolution depended upon the quality of the scanner, transmission line, and the printer. Analog fax machines are obsolete and no longer manufactured. ITU-T recommendations T2 and T3 were withdrawn as obsolete in July 1996. Group 1 faxes conform to the ITU-T recommendation T2. Group 1 faxes take 6 minutes to transmit a single page, with a vertical resolution of 96 scan lines per inch. Group 1 fax machines are obsolete and no longer manufactured. Group 2 faxes conform to the ITU-T recommendations T30 and T3. Group 2 faxes take 3 minutes to transmit a single page, with a vertical resolution of 96 scan lines per inch. Group 2 fax machines are almost obsolete, and are no longer manufactured. Group 2 fax machines can interoperate with Group 3 fax machines. Digital. A major breakthrough in the development of the modern facsimile system was the result of digital technology, where the analog signal from scanners was digitized and then compressed, resulting in the ability to transmit high rates of data across standard phone lines. The first digital fax machine was the Dacom Rapid Fax, first sold in late 1960s, which incorporated digital data compression technology developed by Lockheed for transmission of images from satellites. Group 3 and 4 faxes are digital formats, and take advantage of digital compression methods to greatly reduce transmission times. Group 3 faxes conform to the ITU-T recommendations T30 and T4. Group 3 faxes take between 6 and 15 seconds to transmit a single page. The horizontal and vertical resolutions are allowed by the T4 standard to vary among a set of fixed resolutions: horizontal 100 scan lines per inch, vertical 100 scan lines per inch. Horizontal 200 or 204 scan lines per inch, vertical 100 or 98 scan lines per inch, vertical 200 or 196 scan lines per inch, vertical 400 or 391 scan lines per inch. Horizontal 300 scan lines per inch, vertical 300 scan lines per inch. Horizontal 400 or 408 scan lines per inch, vertical 400 or 391 scan lines per inch. Group 4 faxes conform to the ITU-T recommendations T563, T503, T521, T6, T62, T70, T411 to T417. They are designed to operate over 64 kbits digital ISDN circuits. The allowed resolutions, a superset of those in the T4 recommendation, are specified in the T6 recommendation. Fax over IP can transmit and receive pre-digitized documents at near real-time speeds using ITU-T recommendation T38 to send digitized images over an IP network using JPEG compression. T38 is designed to work with VoIP services and often supported by analog telephone adapters used by legacy fax machines that need to connect through a VoIP service. Scan documents are limited to the amount of time the user takes to load the document in a scanner and for the device to process a digital file. The resolution can vary from as little as 150 dpi to 9600 dpi or more. This type of faxing is not related to the email-to-fax service that still uses fax modems at least one way. Class: computer modems are often designated by a particular fax class, which indicates how much processing is offloaded from the computer's CPU to the fax modem. Class 1 fax devices do fax data transfer where the T4 per ton 6 data compression and T30 session management are performed by software on a controlling computer. This is described in ITU-T recommendation T31. Class 2 fax devices perform T30 session management themselves, but the T4 per ton 6 data compression is performed by software on a controlling computer. The relevant ITU-T recommendation is T32. Class 2.0 is different from Class 2. Class 2.1 is an improvement of Class 2.0. Class 2.1 fax devices are referred to as Super G3. They seem to be a little faster than Class 12.0. Class 3 fax devices are responsible for virtually the entire fax session, given little more than a phone number and the text to send. These devices are not common. Data transmission rate: several different telephone line modulation techniques are used by fax machines. They are negotiated during the fax modem handshake, and the fax devices will use the highest data rate that both fax devices support, usually a minimum of 14.4 kbits for Group 3 fax. Note that Super Group 3 faxes use V34 bus modulation that allows a data rate of up to 33.6 kbits. Compression, as well as specifying the resolution, The ITUT4 recommendation specifies two compression methods for decreasing the amount of data that needs to be transmitted between the fax machines to transfer the image. The two methods defined in T4 are modified Huffman and modified Reed, optional. An additional method is specified in T6, modified Reed. Later, other compression techniques were added as options to ITUT recommendation T30, such as the more efficient JBIG for B-level content, and JPEG, T43, MRC, and T45 for grayscale, palette, and color content. Fax machines can negotiate at the start of the T30 session to use the best technique implemented on both sides. Modified Huffman. Modified Huffman, specified in T4 as the one-dimensional coding scheme, is a codebook-based run-length encoding scheme optimized to efficiently compress white space. As most faxes consist mostly of white space, this minimizes the transmission time of most faxes. Each line scanned is compressed independently of its predecessor and successor. Modified Reed, specified as an optional two-dimensional coding scheme in T4, encodes the first scanned line using MH. The next line is compared to the first, the difference is determined, and then the differences are encoded and transmitted. This is effective as most lines differ little from their predecessor. This is not continued to the end of the fax transmission, but only for a limited number of lines until the process is reset and a new first line encoded with MH is produced. This limited number of lines is to prevent errors propagating throughout the whole fax, as the standard does not provide for error correction. MR is an optional facility, and some fax machines do not use MR in order to minimize the amount of computation required by the machine. The limited number of lines is 2 for standard resolution faxes, and 4 for fine resolution faxes. Modified Reed. The ITUT6 recommendation adds a further compression type of modified Reed, which simply allows for a greater number of lines to be coded by MR than in T4. This is because T6 makes the assumption that the transmission is over a circuit with a low number of line errors such as digital ISDN. In this case, there is no maximum number of lines for which the differences are encoded. JBIG. In 1999, ITUT recommendation T30 added JBIG as another lossless B-level compression algorithm, or more precisely a fax profile subset of JBIG. JBIG compressed pages result in 20% to 50% faster transmission than MMR compressed pages, and up to 30 times faster transmission if the page includes halftone images. JBIG performs adaptive compression, that is both the encoder and decoder collect statistical information about the transmitted image from the pixels transmitted so far, in order to predict the probability for each next pixel being either black or white. For each new pixel, JBIG looks at 10 nearby, previously transmitted pixels. It counts how often in the past the next pixel has been black or white in the same neighborhood, and estimates from that the probability distribution of the next pixel. This is fed into an arithmetic coder, which adds only a small fraction of a bit to the output sequence if the more probable pixel is then encountered. The ITUT85 fax profile constrains some optional features of the full JBIG standard, such that codecs do not have to keep data about more than the last 3 pixel rows of an image in memory at any time. This allows the streaming of endless images, where the height of the image may not be known until the last row is transmitted. ITUT30 allows fax machines to negotiate one of 2 options of the T85 fax profile. In basic mode, the JBIG encoder must split the image into horizontal stripes of 128 lines, and restart the arithmetic encoder for each stripe. In option mode, there is no such constraint. Matsushita white line skip, a proprietary compression scheme employed on Panasonic fax machines, is Matsushita white line skip. It can be overlaid on the other compression schemes, but is operative only when 2 Panasonic machines are communicating with one another. This system detects the blank scanned areas between lines of text, and then compresses several blank scan lines into the data space of a single character. Typical characteristics: Group 3 fax machines transfer one or a few printed or handwritten pages per minute in black and white at a resolution of 204A, 98 or 204A, 196 dots per square inch. The transfer rate is 14.4 kbits or higher for modems and some fax machines, but fax machines support speeds beginning with 2400 bits and typically operate at 9600 bits. The transferred image formats are called ITUT fax group 3 or 4. The most basic fax mode transfers black and white colors only. The original page is scanned in a resolution of 1728 pixels line and 1145 lines page. The resulting raw data is compressed using a modified Huffman code optimized for written text, achieving average compression factors of around 20. Typically a page needs 10 AS for transmission, instead of about 3 minutes for the same uncompressed raw data of 1728A, 1145 bits at a speed of 9600 bits. The compression method uses a Huffman code book for run lengths of black and white runs in a single scanned line, and it can also use the fact that two adjacent scan lines are usually quite similar, saving bandwidth by encoding only the differences. Fax classes denote the way fax programs interact with fax hardware. Available classes include Class 1, Class 2, Class 2.0 and 2.1, and Intel CAS. Many modems support at least Class 1 and often either Class 2 or Class 2.0. Which is preferable to use depends on factors such as hardware, software, modem firmware, and expected use. Printing process. Fax machines from the 1970s to the 1990s often used direct thermal printers with rolls of thermal paper as their printing technology, but since the mid-1990s there has been a transition towards plain paper faxes, thermal transfer printers, inkjet printers and laser printers. One of the advantages of inkjet printing is that inkjets can affordably print in color. Therefore, many of the inkjet-based fax machines claim to have color fax capability. There is a standard called ITUT30E for faxing in color. Unfortunately, it is not widely supported, so many of the color fax machines can only fax in color to machines from the same manufacturer. Stroke speed. Stroke speed in facsimile systems is the rate at which a fixed line perpendicular to the direction of scanning is crossed in one direction by a scanning or recording spot. Stroke speed is usually expressed as a number of strokes per minute. When the fax system scans in both directions, the stroke speed is twice this number. In most conventional 20th century mechanical systems, the stroke speed is equivalent to drum speed. Fax paper. As a precaution, thermal fax paper is typically not accepted in archives or as documentary evidence in some courts of law unless photocopied. This is because the image-forming coating is eradicable and brittle, and it tends to detach from the medium after a long time in storage. Internet fax. One popular alternative is to subscribe to an internet fax service, allowing users to send and receive faxes from their personal computers using an existing email account. No software, fax server or fax machine is needed. Faxes are received as attached TIFF or PDF files, or in proprietary formats that require the use of the service provider's software. Faxes can be sent or retrieved from anywhere at any time that a user can get internet access. Some services offer secure faxing to comply with stringent HIPAA and Grammar Leach Act requirements to keep medical information and financial information private and secure. Utilizing a fax service provider does not require paper, a dedicated fax line, or consumable resources. Another alternative to a physical fax machine is to make use of computer software which allows people to send and receive faxes using their own computers, utilizing fax servers and unified messaging. A virtual fax can be printed out and then signed and scanned back to computer before being emailed. Also, the sender can attach a digital signature to the document file. See also. References. External links. Group 3 Facsimile Communication, a 97 essay with technical details on compression and error codes, and call establishment and release. ITUT 30 Recommendation.